So this is the first lecture for macroeconomics class, okay? And topic is Solow model. So in macroeconomics, we have different models, and one of the most important models related to growth is Solow model. Okay, when we say growth model, it's basically about growth of output. Okay, it's about growth of output, and we also call it output or income. Okay, so basically the assumption is that price of everything is 1. Okay, so in value terms, output becomes equal to income. Okay, if price of everything is equal to 1, then if you multiply price with output, which will be equal to total expenditure, and it is equal to total income because someone has spent that money on that or for that expenditure, right? So price into that output is equal to expenditure, which will be actually equal to income of all the people in the economy. Okay, so since price is assumed to be 1, so output ultimately becomes equal to income. So that's why we say that output and income is same. Okay, all right. So the thing is that this model was given by Robert Solow, and he was from MIT, and he also won the Nobel Prize for this. Okay, so now from now on, you are expected to know all these details as well because of CUET exam. So they can ask these type of questions that who gave which model, and when did someone win the Nobel Prize? Okay, all those type of questions as well. So you are expected to know this. So Robert Solow gave this model, and Robert Solow is actually a neoclassical economist. So broadly, the period of economics is divided into 2 parts broadly. So one is classical economics, and the other one is neoclassical economics. So roughly before 1890, we say that it was the period of classical economics, which started with Adam Smith. So you must have heard the name of Adam Smith. He's called the father of economics. Okay, so broadly 17th and 18th century period comes under classical economics, right? Because classical economics starts with 1776 when Adam Smith gave his first book, Wealth of Nations. Okay, he gave his first book. His book was published, whose name was Wealth of Nations in 1776. So broadly 17th and 18th century comes under classical economics, and period after that it comes under neoclassical economics. Okay. So the basic difference in terms of growth model regarding to classical and neoclassical economics is the basic question. So both classical economists and neoclassical economists gave some theory regarding with regards to growth model. Okay, so the basic difference comes with the answer to this question. So the question is that when is an economy capable of steady growth? Okay, when is an economy capable of steady growth? So the thing is, we all are very well aware of the business cycles, right? So economy at first grows up, reaches at its top, then starts going down, recession aata hai, depression aata hai, and this cycle keeps on going, right? Boom aata hai, recession aata hai, depression aata hai, so this whole thing keeps on going on, right? So ऐसे में an interesting question is that what is an economy, when is an economy capable of steady growth? By steady we mean constant growth, okay? So if with time changes keep on happening in the economy, then when is an economy capable of steady growth? So classical economists said that and without any proof, okay? So without any proof, they said that when national savings is equal to capital output ratio plus rate of growth of labor force. So they said that when this thing holds, then economy is capable of steady growth. So पहले इस बात को समझ लेते, then that what this equation actually means. So basically they are talking about two things. That here they're talking about capital supply. With regards to output, they're talking about capital supply. And in economics, capital basically means machinery, equipments. So they are all the inputs, okay? Machinery, equipments, tools, office, furniture, all those things. So capital supply, and here they are talking about labor supply. Okay, basically workers. So this equation is basically talking about a balance, because so they are saying that when there is some optimal ratio of capital and labor in the economy, and they are supported by the funding, national savings act as a funding for all those things. Capital के लिए पैसे चाहिए, labor को देने के लिए पैसे चाहिए. So this is provided by the this will be under national savings, right? So when this growth of labor and capital is supported by some kind of funding, okay, then they say that economy is capable of constant growth, okay? So labor keeps on flowing in the economy, capital keeps on flowing in the economy, and this is supported by some kind of funding, okay? So this balance is supported by national savings. So when this thing happens, they say that theoretically, they just say this theoretically, that in that case, economy is capable of constant growth. But then there comes Solow, okay? So he totally busted this theory. He says that this equation is just theoretical, okay? And at the same time, it is just a static view. By static basically means not dynamic, which means it doesn't change with time. It is not a dynamic theory, okay? And their national savings are source of funding. Okay, so it is a static view, it is not dynamic. And the thing is, business cycles keeps on happening in the economy. So that means things keep on changing over time, and this theory doesn't even consider that, okay? So this equation can hold at a particular time and it won't hold again, okay? So it will keep on changing. So economy will be in a constant state of equilibrium and disequilibrium. So at some point it will hold, at the other time it will not hold. So it doesn't answer all the questions with regards to constant growth, okay? So it is a static view. That means with time, when things change, when there are changes in the variables, there is change in the growth rate, there is change in the amount of resources, there is change in the behavior of people, their theory it will not be able to answer all the things required. Okay, so there will be up downs in the economy. So how will this growth be steady? Okay, so even if this equation holds for some time, then it cannot remain steady. Okay, so another question they asked was about Great Depression. So let's say in any event, if any event like Great Depression, it occurs, and a few economists are asked to explain a policymaker that why did it occur. Okay, if any event like Great Depression occurs, and a few economists are asked to explain a policymaker. So policymaker is most of the time different from the economists. So economists mostly suggest the ministers. Okay, so they have the power to make decisions, ministers. So basically they become the policymakers and economists suggest them. Okay, and at times, obviously, if an economist becomes a minister, then he's a policymaker at the same time. So are asked to explain a policymaker that why did it occur. Now the problem with classical is that there are so many different kind of variables that are involved there. Okay, so a policymaker, he depends upon economists. Okay, and there are a lot of economists that have been hired there. Let's say there are 10 economists in that committee. Okay, so the thing is that there will be too many ideas, right? Each of them has a different view. They'll give you so many ideas that this might be the reason or that might be the reason. So due to that, there will be too many variables. Okay, so if growth is hampered, then different economists can say that the reason is that there is a change in that variable or this variable. So there are too many variables. Okay, and main problem is there is no set of reliable assumptions in classical economics. No set of reliable assumptions. By reliable, we mean some practical kind of assumptions that we can accept. Okay, that this can be the foundation for a model. Okay, so for any good model, you need it to be as precise as possible. There has to be some reliable assumptions behind that. Okay, and you cannot have too many variables, otherwise you won't be able to reach to a particular conclusion. Okay, so a model is required to understand a situation in a simple manner. Okay, so if there are less number of variables, there are some practical assumptions, then the conclusion that is derived from that model, okay, can be reliable. Okay, so this becomes too complicated for a policymaker to take a decision. Okay, so that's why we need a system or a model which relies on relatively small number of variables, a system which is more than just some guesswork. Okay, and I am using the word guesswork because this equation is simply a guesswork. This is just a theory. This hasn't been proven. This hasn't been checked using the data. Okay, but Solow, what he did was that he took 50 years of data of US economy and checked that what are the main variables behind the growth. All right. And one of the main variables which classical economists totally missed was technology. So US economy relied on technology to a great extent. Okay. So classical economics totally missed that variable. So basically, you need to create a system or a model with relatively less number of variables, relatively small number of variables, small number of, I should say, non-variables, because there are a lot of variables you aren't aware of, or you don't have any data about that. Okay, about them. So if you don't have the data, then that variable is useless for you. So you need a system which is more reliable, than some guesswork. Okay. So there was no visible growth theory. There was no viable growth theory. There was no viable growth theory before Solow. Okay. So three main things he noticed in that data. So his theory is based on capital supply, labor supply, and the most important one is technology. Okay. So it is also called innovation waves. Solow called them innovation waves. And these innovation waves are growth transformers. So a few examples can be like railway tracks. Okay, they come under some kind of innovation. So it will ease the process of transportation, electricity, telephone, internet. So all of these things come under technology and innovation. All right. So how does this affect anything? So whenever there is a technological advancement, so technological advancements lead to productivity increase, right? And if productivity increases, then definitely there will be growth of income and wages as well. Now the question is, what actually is productivity? Okay, what is productivity? Productivity basically means, when we say that there is a increase in productivity, it basically means that you can produce more with less output. Okay. produce more with relatively less output. आप जिस भी situation से compare कर रहे हो, as compared to that, there is relatively you have to use now less input to produce the same level of output, or you can produce more output with even lesser input. So that is even more productivity. So produce more with relatively less input. In numbers, you can say that, let's say some output depends only on labor. Okay. So suppose earlier using 20 workers, you were able to produce 100 units of output, and now you are able to produce the same output, but with less number of workers, then that is a productivity increase, right? And this thing is mostly enabled by technology. Okay. So let's say the output is output is measured under the let's say that the number of kilometers you travel. Basically, I'm talking about transportation. Okay. So earlier, let's say you were able to transport some of your goods to 20 kilometers in, let's say, 5 hours. But when there was railway tracks, now you are able to do the same transportation in, let's say, in 1 hour. Okay, so that's a productivity increase enabled by technological advancement. Okay, so all of this is what we need to study about. So let's now focus on the actual model that Solow gave. Okay. So let's begin. So far we have understood the importance of Solow model and how it took different variables using the data. Okay. Now let's see all the assumptions, because every model relies on certain assumptions on which that model is built. The first one is that there is a single commodity. Okay, so there is only one commodity that is to be produced. The thing is, again, this is a reliable assumption. Then the reason is that if you understand something related to single commodity, then you can extend that model towards more commodities as well. Okay, so if we just assume that there is a single output, there is a single good that is being produced, then obviously if you understood that, then you can do the same thing for other goods as well. So taking single commodity simplifies the model, and at the same time there is no loss of generality. Okay, and this single commodity is used for consumption as well as for investment. Okay, so I can give you an example. For example, corn. Okay, you can consume corn directly, and sorry, you can consume it directly as well as you can invest it for further production. You can use that corn as a seed as well, right? So you can use that seed, plant it again, okay, and that will produce more corn. Okay, so sometimes we also call it corn economy, where the commodities both can be used for both consumption as well as for investment. Okay, so initially we'll assume that there are only two factors of production. We are ignoring technology for now. There are two factors of production. So first we'll deal with this, and then we'll include technology later. So those two factors are labor, we already talked about it, basically workers, and capital. Okay, labor is basically workers and capital is basically about equipments, tech, tools, machinery, etc. Okay. So in every model, there are certain symbols that we need to use. Okay, we cannot obviously name the whole thing again and again. We need to use some certain symbols. So we'll use the symbol LT to represent labor input at time period T. Okay, and we'll use the symbol KT to represent capital input at time period T. Because symbol C is already reserved for consumption. Okay, so since C is used for consumption already, so we use K for capital. Okay, and we don't use C for it. So right now what we are assuming is that there is some initial level of labor and capital already present in the economy. Initially, we are exogenously given total endowment of labor and capital. So let's first understand the word exogenous. So in economics, exogenous basically means that it is given from outside the model. Given from outside the model. We have not derived it. Okay. That is something we are already given. We have not derived it. It is not derived from the model. Okay, so you already have it. So that means initially, so the time period that we are talking about is, so initial level is 0. Okay. So when time period T is equal to 0, so that's your initial period. Then we have time period 1, then we have time period 2, and so on. All right. So initially, we are given some level of labor and some level of capital. So L0 and K0 is the initial level of labor and capital already present in the economy. All right. So we need that. And on that we can develop. So we can say that after we have certain amount of workers in the economy and some amount of capital in the economy, so we have initially some kind of equipments available. So even if you talk about a very initial period of human time, जहाँ पर production शुरू होता है, so maybe you can say that stones, okay, or tools which are made up of stones are the initial level of capital, right? And the initial number of human beings available is your initial amount of workers. Okay, so you can see that. So that is the amount of L0 and K0, the initial amount of labor and capital already present in the economy. And then we need a production function, which will tell us that in what amount you'll use labor and capital and what will be the resulting output due to that. So we use the symbol Y for output. Okay, so YT will be amount of output at time period T. Okay, so output is a function of labor and capital. So output at time period T is a function of labor at time period T and capital at time period T. All right. So So we have a production function, and apart from that, there is a constant fraction of total output which is saved. A constant fraction of total output is saved. And this saving propensity is exogenously fixed. Again, this is given from outside the model. We cannot derive it. So it's something like national saving rate. Okay. So overall, we can find an average that let's say there are 1,000 households in an economy, and this saves, let's say, 10% of its income. Someone saves, let's say, 5% of its income, and household number 100 saves, let's say, 9% of its total income. We can find an average of that, and that will be our national economy. So we can assume certain fraction, okay, and we can use that in our model to reach at some certain conclusions, right? So again, there is no loss of generality. So we can work with any saving rate, okay, and that will help us to reach a conclusion. Okay, so assuming that there is some constant fraction of saving rate from given from outside the model will not harm anything. Okay, so again, it's a reliable assumption. We cannot derive it from inside the model, because that will, if we try to do that, then that will simply increase the number of variables. Okay, so many times we require simplicity, and make, if you want to increase the reliability of the model, that actually comes at a cost. That comes at the cost of complication. Okay, when you increase the reliability of the model, when you make it more and more practical, it will increase the complication because number of variables also increase. Okay, so if you want to avoid that complication, then you'll have to compromise at some level. Okay, so just keep that in your mind. Okay, so saving propensity is exogenously fixed, and we denote it by symbol small s. Okay, and it lies between 0 and 1. Saving rate lies between 0 and 1. So it's a fraction. Okay. So if savings is equal to capital S, income is equal to Y. So let's say income is equal to 100, savings are equal to 10. So saving rate will be equal to 10 upon 100, which is equal to into 100, which is equal to 10%. Okay. All right. So definitely this, or you can say that it is saving rate is equal to 0.1. Okay. So this saving rate is always a fraction. Okay. Now there is a very crucial assumption. The crucial assumption is that all savings are invested. Okay, again, we are not making the model much complicated. What we are saying is that everyone who saves invests his whole amount. Okay, he does not keep anything with himself. All right, because that will uselessly complicate the model, because you don't know that how much a particular person will keep with himself and how much he will invest in the economy. Okay, so we can simply assume that every amount saved is also invested. All right, so that's a crucial assumption, and we'll use that. Now an important point is, which is very obvious, that income is either saved या तो आप सेव करोगे और इट इज कंज्यूम्ड, राइट? या तो आप इनकम को सेव करते हो या फिर आप उसे कंज्यूम कर लेते हो बाय डूइंग सम काइंड ऑफ एक्सपेंडिचर. सो इनकम, दैट इज वाई, is equal to consumption plus savings. Okay, y is equal to c plus s. Yeah, and using this assumption, saving at any particular period of time will be equal to the investment at that particular period of time. Okay, so this is not equal sign, this is actually identity. Here I have used 3 lines, not 2. Okay, this is an identity. Something that is true by definition. Okay, so I already defined here that all savings are invested. So that basically implies that savings will always be equal to investment. Okay, so that's an identity. So this is something that is true by definition. I have already defined it. So now it is equal to saving rate into YT. Yeah. Here I just showed that saving rate is equal to amount of savings upon income. Okay, and saving is also equal to investment. So saving rate into y will be equal to y, and it is true for any period of time. Okay, so saving rate into income is equal to investment. So since y is equal to c plus I, so c plus I can write it as s into y. Okay, because s is equal to I. Saving is equal to investment. Now another variable is depreciation. So existing capital. So we are going slow right now because we are introducing the model right now. I need you to understand each and every variable very clearly. Okay, so existing capital depreciate at a constant rate, and we'll use the symbol delta for it. Okay, the symbol is called delta, and depreciation basically means that wear and tear. So when you use, let's say, machinery, with time its value and its productivity also decreases. Okay, so with time, the amount or the productivity of any machinery or any equipment, it decreases. So that is what we call wear and tear. Okay, so in technical terms it is called depreciation. So y is equal to c plus s, which is equal to c plus saving rate into y. Okay, we know this now. Let's understand this. Let's create a table. We have time period t, we have labor, we have capital, we have production function, which depends upon labor and capital. Okay, we have savings, and then we also have consumption. Okay, Okay. So the initial time period is 0. Okay. So at time period 0, labor is equal to L0. It is already given to us. Capital is equal to K0. It is already given to us. And then using labor and capital, I can produce some output. Okay. Which is equal to what? It is equal to Y0. Okay. Y0 is equal to what? F of L0 and K0. तो सेविंग्स कितनी हो जाएंगी? सेविंग्स विल बी इक्वल टू जितना आपका सेविंग रेट है इनटू द अमाउंट ऑफ इनकम. Yes, and consumption will be what? So whatever is left out of this income, that will be savings. So 1 minus saving rate is the amount of consumption rate, right? 1 minus saving rate is the amount of consumption rate. So consumption rate into the amount of income you have, that will give you consumption. Okay. So Y is the symbol we are using for output. So Y0 is the amount of output produced at time period 0 using labor and capital at that time period. Okay. And then there comes time period 1. So at time period 1, the labor is L1, capital is K1, and output will be Y1, and it depends upon labor at time period 1 and capital at time period 1. Now understand this. What about K1? How will we get K1? K1 will be equal to amount of capital that you already have, okay, minus the amount of capital that gets depreciated. Okay, this is the amount of capital that we already have at time period at the initial time. Okay, then there is some fraction of capital gets depreciated, gets worn out. Okay, so let me give an example. So let's say initially the value of your capital or the level of your capital is 10, and delta is equal to 0.1, which is 10%. So the amount of depreciation कितना हो जाएगा? Delta into 10 will be the amount of depreciation. Okay, so which is equal to 1. 0.1 into 10, which is equal to 1. So this is the amount of depreciation. Okay, so initial level of capital minus the depreciation. Okay, now what is this? This is undepreciated capital. This is the amount of capital left after depreciation. So this is undepreciated capital. And then you'll also do some investment. Okay, आपने टाइम पीरियड 0 में कुछ इन्वेस्टमेंट भी करी होगी, so plus I0. So this is the initial level of capital minus the amount of depreciation plus you invested something, so that becomes the capital at time period 1. Okay, is that clear? Okay. Similarly, savings will be what? S into Y1, and consumption will be 1 minus saving rate into Y1. Okay, so this thing is called law of motion of capital. I'm repeating this line. You have some initial level of capital. Some of it gets depreciated in time in the period between 0 and 1. Okay, यहाँ पर कुछ depreciation हुआ in this time period. यहाँ पर depreciation भी हुआ, यहाँ पर आपने investment भी किया, and initially you had K0. So after this depreciation and after this investment, you reach to K1. Okay, so आप initial capital में depreciation is reduced and you do some investment in that period, and finally that becomes capital in time period 1. Okay, अब clear है? So this is law of motion of capital. So whatever is happening here between 0 and 1. So here we have discrete time periods. Okay, discrete means we are not talking about time in fractional ways. Okay, so these are whole numbers. Time period 0, then something happens in between time, then you get to time period 1 and so on. Okay, हर सेकंड कुछ नहीं हो रहा है, हम बात करेंगे डिस्क्रीट टर्म्स में. तो सिमिलरली टाइम पीरियड 2 आएगा, labor at time period 2, capital at time period 2, output at time period 2, which will depend upon L2 and K2. Okay, and then there will be saving in time period 2, saving it into output, and then there will be consumption in time period 2. Okay, so this thing will keep on going. So this keeps on going, and in general एक बार K2 की बात कर लेते हैं. What will be K2? K2 will be, so you have some amount of capital in time period 1, then something of somewhat of that gets depreciated. Okay, and then you also do some investment in that time period. Okay, and all of that adds up to capital at time period 2. Okay, again, so at 1 you have K1 amount of capital. Here depreciation happens, here investment also happens. So depreciation is equal to delta into K1. Okay, investment is equal to I1. Okay, so this gets subtracted, this gets added, and you get capital in time period 2. Okay, so this is also called capital accumulation equation. Initially you have K0, then you have K1, which is equal to K0 minus depreciation of K0 plus I0. Then K2 is equal to K1 minus depreciation plus investment. And in general, for any time period T plus 1, next period ki capital will be equal to current period's capital minus depreciation of capital in that time period plus investment done in that time period. Okay, so that gives you the capital of next period. All right, so here delta into KT is equal to depreciated capital okay, and if I take KT common here, so this gives me, so 1 minus delta into KT is what? It is undepreciated capital. Okay, so capital in the next period is equal to undepreciated capital plus investment. Okay, so one question I got here is that if labor growth is not happening, then why it is changing? So I haven't said that it is changing. It is just the name. Okay, I am calling labor in time period 1 L1. I am calling labor in time period 2 L2. L1 can be equal to L2. L1 cannot be equal to L2. We can take any case. Okay, right now it's just a name. I can just write anything in general terms. What actually happens, I'll define it later. Okay, अभी ये सिर्फ नाम है. Just because name is different doesn't mean the value is also different, right? तो मॉडल क्रिएट करते हैं अब. This is the capital equation. This is the capital accumulation equation. Now let's create this model and look at steady state, जिसकी हम बात कर रहे थे constant growth की. Steady state की बात करेंगे. एक क्वेश्चन के थ्रू इस पूरी प्रोसेस को समझते हैं. So initially I am saying that LT is equal to 1 and it is happening for all time periods. Okay. I am simply assuming that labor, the number of workers in every time period is equal to 1. Okay. So it's, you can say that it's like there is one human being. Okay. He gives birth. Okay. It's like amoeba maybe. So it gives birth. Okay. दो हो जाएंगे and one of them dies. Now in time period 1 there is again one human being. Then it gives birth to two. It gives again birth. Okay, and then he himself dies, and then in time period 2 there is again one human being, and so on. So in every time period there is exactly one work. So L0 equal to L1 equal to L2 and so on. All of them are equal to 1. So assuming labor is equal to 1 for all time periods. Which basically means initially I am assuming that labor force does not grow. Okay. Include करेंगे in the next question. For now, there is no labor force growth. We also need a production function. So YT, which is a function of labor and capital in time period T. एक simple सा अभी लेके चलते हैं. Then we'll include more complicated production functions. For now, it is a Cobb-Douglas production function. Okay, this is called Cobb-Douglas production function, where whatever the initial amount of capital is, it is positive. Okay, it can obviously it cannot be 0, because if it becomes 0, then output will always be 0. Okay, फिर आप production कर ही नहीं पाओगे. So initially we have some positive amount of capital, and मैंने कहा था आपको कि इसके बिना आप कर ही नहीं पाओगे, because saving आपको करनी है इनकम में से. अगर इनकम ही नहीं होगी इनिशियली, आप y0 लेवल पर आउटपुट निकाल रहे हो, it will be equal to what? L0 K0 to the power half. K0 is agar 0. If K0 is 0, then Y0 will be 0. If Y0 is 0, then savings will be 0. If savings are 0, then investment will be 0. And if investment is 0, तो K1 भी हो जाएगा 0. Because there is ना capital है, capital नहीं है तो depreciation भी नहीं होगी उसमें से, और investment भी नहीं हो पा रही है. So K1 is 0. Again, next period output will also be 0. So therefore we are assuming that there has to be certain positive amount of capital in the beginning. ठीक है, otherwise हम model को start ही नहीं कर पाएंगे. Okay, so that's why it is an important assumption here. So whenever you see assumption, you should realize the value of that investment कि वो given क्यों है. ये clear है? I am repeating this part. अगर if K0 is 0, then Y0 will also be 0 because K0 is 0. Okay, if this is 0, then output is 0. Okay, if output is 0, then you cannot save anything out of 0 income, right? So saving will also be 0. And if savings are 0, then, and we know that all savings are invested, so investment will also become 0 because savings are equal to investment. So both are equal to 0. And if there is no investment, we know that capital in next period is equal to what? K0 minus depreciation plus investment, right? So K0 is 0. Depreciation also becomes 0 because K0 is 0. Delta into 0 is 0. Plus investment is 0. So K1 is also 0. And if K1 is 0, then Y1 is what? Y1 will be L1 to the power half, K1 to the power half from this production function. So K1 is 0. So L1 to the power half into 0 to the power half is also 0. So Y1 is 0. Okay. So this implies that Y1 is also 0. And if Y1 is 0, then this thing will keep on happening. फिर से 0 savings, फिर से 0 investment. So YT in general will become 0. And there is no use of this model, right? So therefore, initially we have assumed that K0 has to be positive. Okay. अभी clear है? So YT क्या हो गया? YT आपके पास था LT to the power half, KT to the power half. We know that LT is equal to 1 for all time periods. So YT, which is a function of labor and capital, will be equal to what? LT की जगह आ जाएगा 1. Okay. KT. So it will be equal to 1 to the power half into KT to the power half. So in general, we have YT equal to KT to the power half. Okay, इस particular model में. So in this particular case, growth rate of जो output होगा, output की जो growth है, that depends only upon growth of capital. अगर capital grow करेगा, तभी output grow करेगा. In this particular case, okay, we are solving a question. So growth rate of output is generated by the growth rate of capital in this particular economy. Okay. And we also know that capital जो grow करेगा, capital grows with the help of what? Investment. Capital grows due to the investment, right? And we know the capital accumulation equation. So KT plus 1 will be is equal to what? 1 minus delta into KT. That means undepreciated capital plus investment in time period T. Okay. So it is equal to 1 minus delta into KT plus saving rate, okay, into income. This is saving, and saving is equal to income. Saving is equal to investment. Okay, saving is equal to saving rate into income, and saving is also equal to investment. So investment is equal to SYT. Okay, and YT हम calculate कर चुके हैं. It is equal to KT to the power half. So ultimately, capital accumulation equation is equal to undepreciated capital plus saving rate into KT to the power half. यहां तक क्लियर है? जल्दी समराइज कर दूं मैं आपको यहां पर क्या क्या करा हमने, फटाफट देखो. इनिशियल लेवल ऑफ कैपिटल वो पॉजिटिव है. लेबर हर टाइम पीरियड में 1 है. ठीक है, ये एक सीक्वेंस का सिंबल यूज कर रहा हूं मैं यहाँ पर. सीक्वेंस है, टी शुरू हो रहा है 0 से लेके इन्फिनिटी तक. तो ये बेसिकली कह रहा है L0 इक्वल टू L1 इक्वल टू L2 इक्वल टू जहां तक भी जा रहा है इक्वल टू 1. ठीक है, तो आई कीप ऑन इंट्रोड्यूसिंग न्यू सिंबल्स बिकॉज not to make it complicated, but because these symbols are often used in the entrance exam, so you should be aware. Okay, otherwise you won't be able to understand the question. So I keep on introducing different symbols so that you already know them when you get to exam. Next, we know that saving rate is between 0 and 1. Delta is positive, depreciation rate is something positive, and you are given a production function which depends upon labor and capital. Okay, and we also know that KT plus 1, which is the capital accumulation equation, it is equal to undepreciated capital plus investment, which is equal to S into KT to the power half. ठीक है, इतनी बात हुई है हमारी अभी तक. नाउ लेट्स चेक द रिलेशनशिप बिटवीन kt plus 1 and kt. Okay, so if I differentiate kt plus 1 with respect to kt, that what's the relationship between next period's capital and current period capital, or current period's capital? Okay, so it will be equal to what? 1 minus delta. kt का हो जाएगा 1. सेविंग रेट kt to the power of root x का होता है 1 upon 2 root x, तो 1 upon 2 root kt. Okay, and clearly this part is positive, right? Capital cannot be negative. Negative capital, negative amount of equipments, negative amount of machinery doesn't make any sense. So this thing has to be positive. Okay, s is positive. Yes, s is also positive. Delta is a fraction, right? Depreciation rate. You cannot let's say if amount of capital you have is 10, आप इसमें से 11 depreciate नहीं कर सकते, right? You cannot have a depreciation of more than 10. If the amount of capital is already equal to 10, you cannot have depreciation of 11. हद से हद ये 0 तक चला जाएगा, right? So basically depreciation rate has to be something in fractional terms. It cannot be more than 100%. So this thing is also positive. This thing is also positive. So overall this thing is positive, which means that it is a increasing relationship. So if kt increases, then kt plus 1 also increases. Okay, what else? So let me show you a shortcut. I won't check concavity or convexity right now, but मैं क्या कर सकता हूं, मैं सिर्फ इस स्लोप को इन्वेस्टिगेट करके बता सकता हूं कि ये कॉनकेव आएगा या कॉन्वेक्स आएगा. ठीक है, डायरेक्टली व्हाट आई कैन डू इज आई कैन इन्वेस्टिगेट दिस फंक्शन, दिस डिफरेंशिएशन. ओके, एक बार दिखाता हूं मैं आपको. तो एज kt goes to 0, अगर kt जाता है 0 की तरफ, ठीक है, तो देन दिस थिंग goes to 0. kt goes to 0, then this whole thing will go to infinity. So basically slope will go to infinity when kt goes to 0, right? And as kt goes to infinity, when kt goes to infinity, this thing becomes 0. When kt goes to infinity, this whole thing becomes 0, and slope will be what? 1 minus delta. Then in that case, slope goes to 1 minus delta. ठीक है, तो इनिशियली स्लोप इज इंफिनिटी जब kt 0 है. ये पार्ट क्लियर है? when kt goes to 0, slope goes to infinity, and when kt goes to infinity, slope goes to 1 minus infinity, 1 minus delta. Is it clear? ये फिर से देखो, when kt goes to 0, kt हो गया 0, kt हुआ 0, 1 upon 0 is infinity. So this whole thing becomes infinity, and infinity plus anything is infinity. So slope goes to infinity. ठीक है, and when kt goes to infinity, okay, 1 upon infinity is 0. ठीक है, so this whole thing is 1 minus delta. अब क्लियर है? Okay, and why this thing is positive? सेविंग रेट हमें गिवन है बिटवीन है 0 and 1, पॉजिटिव है. 2 पॉजिटिव ही होता है. रूट के, तो k ऑलरेडी पॉजिटिव है. इफ k इज पॉजिटिव देन अंडर रूट ऑफ दैट इज, वैसे भी अंडर रूट ऑफ एनीथिंग इज ऑलवेज पॉजिटिव. सो एवरीथिंग हियर इज पॉजिटिव, राइट? सो दिस होल थिंग इज पॉजिटिव. ओके, नाउ so on the x-axis we have kt, and on the y-axis we have kt plus 1. ठीक है, initially when kt goes to 0, slope is infinity. ठीक है, कुछ ऐसे होगा. एंड देन इट कीप्स ऑन डिक्रीजिंग एंड इट गोज टूवर्ड्स 1 माइनस डेल्टा विच इज समथिंग फ्रैक्शनल. तो यू कैन नोटिस दैट स्लोप शुरू हो रही है इन्फिनिटी से एंड इट इज गोइंग टूवर्ड्स सम फ्रैक्शन, लेट्स से 0.2. ठीक है, कोई भी फ्रैक्शन हो सकता है. 1 माइनस डेल्टा कैन बी 0.5 और 0.4 डिपेंडिंग अपॉन डेल्टा क्या लिया है हमने. सो द थिंग इज इन्फिनिटी से शुरू हो रहा है, डिक्रीज होते होते 1 माइनस डेल्टा तक जा रहा है. तो बाय दैट आई कैन से दैट शेप कुछ ऐसी होनी चाहिए, बिकॉज स्लोप देखो कीप्स ऑन डिक्रीजिंग डिक्रीजिंग डिक्रीजिंग, इट कीप्स ऑन बिकमिंग फ्लैटर एंड फ्लैटर एंड फ्लैटर. इनिशियली स्लोप इन्फिनिटी है. ओके, सी दिस. अगर मैं यहाँ पर एक टेंजेंट लाइन लूंगा एट जीरो, इट हैज टू बी अ वर्टिकल लाइन बिकॉज स्लोप इज इन्फिनिटी. ओके, इनफाइनाइट स्लोप है यहाँ पर, इनफाइनाइट ढलान है यहाँ पर. ओके, कोई भी गिर जाएगा इसमें. सो इनिशियली अगर मैं इसे स्ट्रेट लाइन बनाऊंगा, दिस इज डेफिनेटली नॉट इन्फिनिटी. अगर मैं इसे कॉनकेव बनाऊंगा, ओके, हेयर स्लोप इज जीरो नॉट इन्फिनिटी. सो डेफिनेटली शेप हैज टू बी, सॉरी कॉन्वेक्स. यहां पर अगर मैं कॉन्वेक्स बनाऊंगा तो इनिशियली स्लोप इज जीरो. सो शेप हैज टू बी कॉनकेव, राइट. ओके, मैंने सिंपली इसे इन्वेस्टिगेट करा. आई सो दैट स्लोप शुरू हो रही है इन्फिनिटी से and it is going towards 1 minus delta which is something fractional. Very high slope से ये जा रहा है कम slope तक. Okay, so it has to be concave, right? Otherwise we can also check it. If I do the second derivative, let me just do that. d2 kt plus 1 by d kt square. मैं second derivative निकाल रहा हूं. So 1 minus delta में kt नहीं बचा, इसका हो जाएगा 0. एंड इसे मैं लिख सकता हूं s by 2 kt to the power minus 1/2. ठीक है, रूट kt इज kt की पावर 1/2. मैं इसे न्यूमरेटर में लेके जाऊंगा तो मुझे माइनस लगाना पड़ेगा पावर में, सो इट इज kt to the power minus 1/2. ओके, सो डिफरेंशिएट करके आ जाएगा s/2 एज इट इज विच इज अ कांस्टेंट minus 1/2 kt की पावर minus 3/2. ओके, विच इज इक्वल टू व्हाट, माइनस बाहर ले जाते हैं, -s/4. I can write it as 1 upon kt to the power 3/2. Okay, s is positive, 4 is positive, kt to the power 3/2 is positive. आगे माइनस का साइन है, so this thing is negative. Okay, so second derivative negative है, which clearly means this has to be a concave function. Okay, now the point here was, if you know how to investigate the slope, you don't have to find second derivative. आप वहीं से कर सकते हो. Okay, ये बात क्लियर है? क्लियर है? So before moving forward, let me tell you what's the purpose here. Purpose is to find steady state. पर्पस हमारा है टू फाइंड द स्टेडी स्टेट. क्या होता है स्टेडी स्टेट? बेसिकली अ इक्विलिब्रियम सिचुएशन. इन इकोनॉमिक्स इक्विलिब्रियम बेसिकली मींस अ बैलेंस सिचुएशन. ओके, मुझे एक बैलेंस्ड सिचुएशन को निकालना है, उसकी बात करते हैं. सो हियर वी हैव, तो बैलेंस सिचुएशन होगी क्या वो सुनो. आई नीड टू फाइंड अ स्टेडी स्टेट इज, I need to find a steady growth rate. Okay, what is steady growth rate? Constant growth rate. Okay, constant growth rate किसकी? Constant growth rate of output. Output यहां किस पर डिपेंड कर रहा है? Output depends only on capital here, right? So constant growth rate of output कब मिलेगा? When capital growth rate is constant, right? कैपिटल का ग्रोथ रेट कांस्टेंट कब होगा? ग्रोथ रेट क्या होता है? kt + 1 minus KT upon KT. This is the growth rate. Okay. I want this to be a constant. And particularly, I want that constant to be 0. मुझे वो ग्रोथ रेट को 0 करना है. अभी उसकी बात करते हैं क्यों, लेकिन अभी मुझे उसे 0 करना है. एंड मेक श्योर, अभी मैंने जनरलिटी नहीं खोई है. कांस्टेंट 0 इज आल्सो अ कांस्टेंट, राइट? नाउ दिस मींस दैट KT + 1 इज इक्वल टू KT. मुझे इस सिचुएशन में जाना. ओके, and this part is more interesting, okay, rather than any other constant. And the reason is that ये क्या बता रहा है आपको, हर पीरियड में क्या हो रहा था, when you are going from, let's say, from K0 to K1, क्या हो रहा था, कुछ डेप्रिसिएशन हुई, कुछ इन्वेस्टमेंट हुई. ठीक है. इट बेसिकली, दिस इक्वेशन बेसिकली इज सेइंग दैट कि K1 इक्वल टू K0 कर दो, राइट? अगर मैं t की जगह 0 कर दूं, then that would mean that K1 is equal to K0. If t is equal to 0, then this would mean that K1 is equal to K0. ठीक है. So in general, अगर मैं इसको लेके चलूं, तो अगर K1 is equal to K0, then what that means, ये कैंसिल आउट हो जाएंगे. So you'll get I1 equal to delta into K0. Okay, which basically means you want investment to be equal to depreciation. Okay, so that's the interesting part. What you're doing here is that you are investing the exact amount which is being depreciated from the economy. Basically, you are replacing the depreciated capital by the exact amount of investment. Okay, so जब आप उतना ही इन्वेस्ट कर रहे हो जितना डेप्रिशिएट होगा, so capital is being replaced. तो कैपिटल हर पीरियड में, तो एक बार अगर आप यहां पर पहुंच गए, if you are in the situation where investment is always equal to depreciation, then there will be a constant growth of capital which is 0. 0 का growth rate होगा, और y output का भी वही growth rate होगा, and that is what we call a steady state. Okay, there will be no change from that state. Okay, so that's what we are interested in, and here it will be 0. Okay, so इन्वेस्टमेंट हमें चाहिए इक्वल टू डेप्रिसिएशन के, या फिर KT हमें चाहिए इक्वल टू KT + 1. दैट्स इट. इज इट क्लियर? So we know that इसकी शेप है concave. Okay, I want a situation where KT is equal to KT + 1. So for that I'll use a 45-degree line. So हमें पता है 45-degree line क्या रिप्रेजेंट करती है. 45-degree line represents that जो भी यहाँ वेरिएबल, इट इज इक्वल टू द वेरिएबल ऑन द y एक्सिस. सो x इज इक्वल टू y. दिस इज रिप्रेजेंटेड बाय अ 45-degree line. तो ये लाइन क्या रिप्रेजेंट करे, दिस डॉटेड लाइन रिप्रेजेंट्स KT is equal to KT + 1. This is a 45-degree line. Okay, so तो जहां जहां wherever this dotted equation intersects this capital accumulation equation, at all those points KT will be equal to KT + 1, right? If this dotted line is representing KT equal to KT + 1, so wherever this dotted line intersects the capital accumulation equation, at all those points we have this relationship holding. Okay, so this relationship holds at this point, and this also holds at this point. Okay, ये बात क्लियर है? So this is the general case. So ये आ गया आपका point 0 का. Okay, and wherever this holds, this equation KT equal to KT + 1 holds, we call that particular capital K star. Okay, and we call it steady state level of capital. Steady state level of capital. Okay, So this is K star. Okay. Now let's understand the law of motion here. तो लॉ ऑफ मोशन क्या है? तो सपोज यू हैव some positive level of capital which is here, okay, which is towards the left of K star. ठीक है, अभी मैं कौन सा केस ले रहा हूं? This is the case where initial amount of capital is less than the steady state of level of capital. Okay, so क्या करा आपने? This is the capital accumulation equation, right? यानी KT plus 1 is equal to KT plus 1 is equal to 1 minus delta into KT plus IT. Okay, so K0 से आपने स्टार्ट किया. K0 से आपको क्या मिल जाएगा? दिस कैपिटल एक्यूमुलेशन वाला जो ये ग्राफ है, दिस प्लॉट इज गिविंग यू द कैपिटल इन द नेक्स्ट पीरियड. ठीक है, ऑन द एक्स एक्सिस यू हैव कैपिटल इन करंट पीरियड, ऑन द वाई एक्सिस यू हैव कैपिटल इन द नेक्स्ट पीरियड. तो अगर यहां पर मैं K0 ले रहा हूं तो दिस ग्राफ विल गिव मी व्हाट? K1. ओके, सो नाउ अब मैं क्या करूंगा? ये 45 डिग्री लाइन जो कि बता रही है मुझे KT इक्वल टू KT प्लस 1 है, आई कैन गेट बैक K1 एज माई करंट पीरियड. अब नाउ आई वॉन्ट टू सी कि K2 कितना होगा. अगेन this by substituting K1 in the capital accumulation equation, this graph will give me capital in the next period. अगर current K1 है तो next period कितना हो जाएगा? K2. ओके, अब मैं क्या कर रहा हूं? मैं वापस इसे 45 डिग्री लाइन पर लेके आ रहा हूं. अंडरस्टैंड दिस प्रोसेस वेरी केयरफुली. मैं क्या कह रहा हूं? K2, this 45 degree line represents that KT is equal to KT plus 1. Okay, if I have K2 here, 45 degree line per KT is equal to KT plus 1, so this will again give me what? K2 as my current period's capital. Okay, एक तरीके से मैं ये डायनामिक चीज एक सिंगल ग्राफ पर देखना चाह रहा हूं. नाउ आई हैव कैपिटल K2 as my current period as my current period's capital. Substituting it back here, okay, when I'll put K2 here, it will give me K3. Okay, so ये this graph will give me back K3. Okay, and again I can take it on the 45 degree line and get K3 as my current period's capital. I'll again substitute it back here. Okay, so this process keeps on happening. Okay, something like this, and at last you reach at steady state. Okay, K0 आपने पुट करा, इन्वेस्टमेंट और डेप्रिसिएशन के बाद आपके पास आ गया K1. ओके, नाउ यू आर यूजिंग दैट K1 एज योर करंट पीरियड्स कैपिटल टू चेक कि K2 कितना होगा. तो उसके बाद आ गया आपके पास K2. ओके, देन यू आर यूजिंग दैट K2 एज योर करंट पीरियड्स कैपिटल टू चेक कि K3 कितना होगा. सेम ग्राफ में हम चेक कर रहे हैं. तो दिस KT इज अ जनरल KT. इसी में ये K0, K1, K2 सारी वैल्यूज लेता जा रहा है. ओके, सो दिस इज अ जनरल वेरिएबल. ओके, so K3, K4 and so on till you reach at K star. Okay, तो ऐसे आप पहुंच जाते हो स्टेडी स्टेट पर, स्टेडी स्टेट लेवल ऑफ कैपिटल पर. दिस इज व्हाट वी कॉल लॉ ऑफ मोशन ऑफ कैपिटल. अंडरस्टूड? चलो फिर से देखते हैं. कुछ नहीं कर रहे हम, इतना कॉम्प्लिकेटेड है नहीं. देखो, KT करंट पीरियड की कैपिटल, KT plus 1 capital in the next period. Capital accumulation equation is giving you this graph. Okay, KT equal to KT plus 1 is this dotted line. Okay, now forget about everything. See this. We begin with K0. This is the initial amount of capital. This graph will give you what? This graph relates KT plus 1 and KT. Okay, so this will give you capital in the next period. All right, 45 डिग्री. एक बात देखो, अगर सब K, KT, वेटी सब भूल जाओ, यहां देखो X इक्वल टू वाई की लाइन है. दिस इज x इक्वल टू वाई। ओके, मैं अगर यहाँ किसी पॉइंट पर हूं, सपोज दिस इज 3, इफ दिस पॉइंट इज 3, तो x एक्सिस पर 3 कहां पर होगा? मैं सिंपली एक हॉरिजॉन्टल लाइन लूंगा, 45 डिग्री लाइन पर आऊंगा, इसे वापस नीचे प्लॉट करूंगा, मुझे क्या मिलेगा? 3 मिल जाएगा, राइट? अगर 3 यहां पर है तो यहां जो 90 डिग्री का एंगल बनेगा वही यहां बनेगा, और ये आपको पॉइंट मिल जाएगा 3 का। सिमिलरली अगर यहां पर 4 है तो सिंपली यहां भी 4 होगा, अगर यहां 1 है तो यहां 1 होगा। ठीक है, तो मैं क्या कर रहा हूं, आई एम फाइंडिंग आउट कि K1 वापस KT पर कहां आएगा, KT वाली लाइन पर। ओके, so if K1 is here, then on x axis K1 will be here. Okay, and अब मैं वापस जब इस इक्वेशन में K1 का यूज करूंगा, यानी इस ग्राफ का जब मैं यूज करूंगा, that graph will return me back K2 because it is giving me capital in the next period. So after depreciation and investment, this K1 will get converted into K2 in the next period, right? और अब मैं यूजिंग माई 45 डिग्री लाइन, मैं क्या कर रहा हूं, मैं वापस यहां लेकर आया, फिर इसे नीचे लेकर आया, तो मुझे पता लग जाएगा कि ये 4 एक्स एक्सिस पर कहां पर है। ओके, सो दिस K2 विल बी हेयर ऑन एक्स एक्सिस, तो ये कर रहे हैं। ओके, सो दिस प्रोसेस कीप्स ऑन हैपनिंग जब तक आप यहां ना पहुंच जाओ। ओके, और यहां पर आके आप क्यों रुक गए हो, इसके बाद आप कुछ कर नहीं सकते। ठीक है, आप यहां पर आगे, नाउ यू आर एट K स्टार। ओके, तो इसे आप नीचे लेकर आओ, मान लो इसका नाम मैंने दे दिया K स्टार। ओके, अब व्हाट विल बी द कैपिटल इन द नेक्स्ट पीरियड? आप देखोगे तो आपको वापस वही पॉइंट मिल जाएगा, राइट? क्योंकि यहां पर 45 डिग्री की लाइन एंड आर कैपिटल एक्यूमुलेशन इक्वेशंस ग्राफ आर इंटरसेक्टिंग ईच अदर, इट विल अगेन गिव यू द सेम पॉइंट। ओके, तो यहां पर K स्टार आ गया, K स्टार से आप वापस अगर इसको नीचे लेके आओगे तो वही पॉइंट आ जाएगा। ओके, तो दिस विल कीप ऑन हैपनिंग। एक बार आप यहाँ K स्टार पर आ गए, एक बार आप इस वाले स्टेडी स्टेट पर आ गए, इट कीप्स ऑन हैपनिंग, एंड अब आप यहां से कहीं और नहीं जा पाओगे। दैट्स व्हाई इट्स कॉल्ड अ स्टेडी स्टेट, दिस इज अ कांस्टेंट स्टेट, आप बाहर नहीं आ पाओगे। ओके, एंड द रीजन इज दिस वन इज अ स्टेबल स्टेडी स्टेट। ओके, अभी एक बार प्रोसेस क्लियर है, फिर मैं जो टेक्निकल मैंने वर्ड्स यूज करे उनको मैं अभी बताऊंगा। टिल नाउ इज द प्रोसेस क्लियर? ठीक है, एंड द सेम थिंग कैन हैपन अगर आप K0 राइट में होगा K स्टार के। ओके, एक बार मैं जल्दी से वो दिखा देता हूं, देन वी विल कंटिन्यू इट इन द नेक्स्ट लेक्चर, कि अगर so this is my cap, this is KT equal to KT plus 1. On the x axis we have KT, on the y axis we have KT plus 1. Now suppose K0 is somewhere to the right of this K star. अगर मैं वहां से स्टार्ट कर रहा हूं, इफ आई एम स्टार्टिंग विथ टू मच कैपिटल, ओके, इफ आई एम स्टार्टिंग विथ टू मच कैपिटल, तो अब K1 मुझे मिलेगा कैपिटल एक्यूमुलेशन इक्वेशन से, राइट? ये ग्राफ मैंने क्रिएट किया है लॉ ऑफ मोशन के लिए। नाउ दिस विल गिव मी K1। ओके, K1 आ गया, K1 अब मुझे वापस एक्सेस पे चाहिए ताकि मैं K2 चेक कर पाऊं। ठीक है, अंडरस्टैंड दिस, आई वॉन्ट K1 back on the x axis so that I can find out K2. Okay, so getting it back, I'll reach on this KT equal to KT plus 1 equation on this line. Okay, now that will return me what? K1। अब K1 को वापस देखेंगे ग्राफ पर, ये वाला पॉइंट आ गया K1 के कॉरेस्पॉन्डिंग, so that will give me K2. Now this 45 degree line will give me K2 on my x axis. Okay, now this graph will give me K3 on the y axis. तो ये चल रहा है। ओके, दिखा? तो अगर राइट से शुरू करोगे तो सिचुएशन विल बी, नीचे देखते हैं, तो सिचुएशन इज समथिंग लाइक दिस। ऐसे ऐसे ऐसे. Now you are moving towards, मतलब अगर आप लेफ्ट से स्टार्ट करोगे then you are moving towards k star from the left. If you are starting from the right side then you are moving towards k star from the right side. Okay, so that's it. So it's something like this from the okay, but you get the process. Okay, थोड़ा सा कॉम्प्लिकेटेड होता है लेफ्ट साइड से बनाना, राइट साइड से बनाना, बट यू गेट द प्रोसेस. ये क्लियर है?
सर इस
So you can say that initially when capital is less than k star, so situation is something like this, that capital is already very less. Okay, and suppose delta is 0.1 or 10%. So then total depreciation will be just 1. Okay, but when capital is towards, initial capital is towards the right of k star, which is, that means we have a lot of capital where there is too much capital. Okay, so let's say k0 is 1000 and let's say depreciation rate is same, but now total depreciation is too much, right? It will be equal to 1000 into 0.1, which is equal to 100. Okay, it is too much. So when capital is too much, then depreciation is also too much. Okay, so as compared to investment, depreciation is more. Okay, so the next period's capital is less than the current period's capital. That's why you are moving towards left side. So k0 say you reached k1 which is less than k0, then you reach k2 which is less than k1, and so on till you reach k star. Okay, अभी clear है? Okay, so now the thing is we had two steady states here. One is at this point, which is a positive steady state level of capital k star, and another is here because at both of these points kt plus 1 is equal to kt. Okay, we have two steady states, k star which is something positive and another one is when k is equal to 0. Okay, that's also a steady state, and this one is a stable steady state, and this one is unstable. And we get a lot of these type of questions in ISI, that you have to check whether a particular steady state is stable or unstable. Okay, so we'll continue from here, that why k equal to 0 is unstable steady state. Okay, and why k star is stable steady state. Basically we need to know the definition of stability. Okay, so tomorrow we'll begin with the definition of stability, and then we'll apply this definition to both of these steady states to check why is it stable and why is it unstable. Okay,